So in this video, I want to show you how we can use our graphing calculator with Cramer's rule. Example: use Cramer's rule with a graphing calculator to solve each system of equations if possible. So in part A, we have two equations with two variables. In part B, we have three equations with three variables that we want to solve. So if I want to use Cramer's rule, I need to find the determinants that are involved. So I need to find D, I need to find dx, and I need to find dy. Well, D is going to be the matrix -2, 3, -3, 4. It is the coefficient matrix, except we're going to use the determinant for that. Then for the determinant dx, we fill in the values of the constants in place of the x coefficients. So we're going to have 4, 5, and then we're still going to have 3, 4, the coefficients for y. And for the determinant dy, we're going to use our D matrix, except we're going to substitute the constants in place of the coefficients of y. So we're going to have -2, -3, those are the x coefficients, and then we're going to put in the constants where the y coefficients were originally. So now I can use my calculator to evaluate these determinants. So if I bring in my calculator, I'm going to go to Matrix, I'm going to edit Matrix A, and it's going to be a 2 by 2 matrix, and I'm going to enter in our D matrix there. So -2, 3, -3, 4. So I have these values entered into matrix A. Second quit to go back to the home screen. I'm now going to evaluate this determinant. So I go to Matrix and Math, select number 1 for determinant, and I want to evaluate the determinant of matrix A, and so that is 1. So this gives me a result of 1. Now I'm going to do the same thing for the dx determinant. So I'm going to go to Matrix, Edit, choose matrix A, and in this case I have 4 and 5 in place of the -2 and -3. So I've just edited that. Second quit. If I go to Matrix, Math, Determinant, Matrix A, so that gives me a result of 1 as well. So this also has a result of 1. Now dy, I'm going to enter that in to matrix A. So I'm going to go to Matrix, Edit, Matrix A, and this time we have -2, 4, -3, 5. So I've entered that in. Second quit. I'm going to go to Matrix, Math, Determinant for Matrix A, and I get 2. So I've used my graphing calculator to evaluate the determinants for me. So x is equal to dx over d, which in this case is 1 over 1, which is 1. Y is equal to dy over d, which in this case is 2 over 1, which is 2. So the solution to our system is the ordered pair 1, 2. Now we can do the same kind of thing for part B. It's just a little more involved because we have three variables. So our D determinant is going to be the 3 by 3 determinant, -3, 4, 2, 2, 3, 1, 5, -6, -3. So again, this comes from the coefficients. We'll evaluate that in a minute in our calculator. The determinant dx is going to be the same determinant, except we're going to replace the coefficients of x with the constants. So I'm going to have 2, -1, 4 down the x column, and then I'm still going to have the 4, 3, -6, the 2, 1, -3, and we'll evaluate that in just a minute. dy, again, is going to be the same as this D determinant, except I'm going to replace the y coefficients with the constants. So this column, -3, 2, 5 is going to stay the same. This column 2, 1, negative 3 is going to stay the same, but I'm going to replace the 4, 3, negative 6 with the constants 2, negative 1, 4. So this would be dy. And dz, again, is going to be the d determinant, except the third column, the z column, is going to be replaced with the constants 2, negative 1, 4. So I can evaluate each of these using my calculator. So if I bring in my calculator, matrix, edit, matrix A, we're going to have a 3 by 3 matrix, negative 3, 4, 2, 2, 3, 1, 5, negative 6, negative 3. Second quit, matrix math, determinant, matrix A. So the determinant of matrix A is negative 1. So this is negative 1. That's D. Now d of x, I'm going to go back to matrix A, and I'm going to replace that first column with the 2, negative 1, and 4. So 2, negative 1, 4. So I'm leaving the rest of that matrix alone. Second quit. And this time I'm just going to do second and enter to pull that back up and say enter. That is negative 14. So d of x is negative 14. We evaluated that determinant. In the same way, I'm going to enter dy now. So if I go back to matrix and edit matrix A, now in this case I need to put the negative 3, the 2, and the 5 back in place, and I need to replace the 4, 3, 6 with the 2, negative 1, and 4. Second quit, second enter to pull back up the determinant of A, and that is 51. So this is 51. And finally we need to do dz. So same process. I have the first column's okay. The second column needs to be 4, 3, negative 6. And now the third column needs to be 2, negative 1, 4. Second quit. Second enter to pull back up, find the determinant of A, and that is negative 124. So this is negative 124. So x is going to equal dx divided by d. So that would be negative 14 divided by negative 1, which would be 14. Y is going to equal dy divided by d, which would be 51 divided by negative 1, which is negative 51. Z is going to equal dz divided by d, which is negative 124 divided by negative 1, which is 124. So the solution to our system is the ordered triplet, 14, negative 51, 124. So again, I can use my calculator to evaluate the determinants so that I can then use Cramer's rule to figure out the solution to the system.